Alright guys, so we're gonna start the chapter 5 test review, obviously starting with 5.1, and then we're gonna do the rest of them. I might chop it down, like I might do 5.1, 2, and 3 in one video, and then 5, 4, 4, 5, 6 in the other, but who knows. Alright, so let's start here. So start 5.1, this is one of our first questions. I might have questions on here that are not on the study guide. If they're on here and they're not on the study guide, they will not be on your exam. It is just here to teach you, because there's some questions that I didn't think were kind of repetitive, but that's the point of studying, is to repeat it and repeat it until you get better at it. So if it's not on your study guide, it will not be on the exam. So please don't fret about that. Okay, so let's take a look at this first one. Use the figure to the right to complete the statement. Triangle AED is blank to triangle AEB. Okay, so we're taking a look at this triangle. Oops. We're taking a look at this triangle and this triangle. Okay, so what do we notice about this triangle? Well, it's a perpendicular bisector, right? This EA is a perpendicular bisector of what segment? DB. And what do we know about a perpendicular bisector and its segment that it bisected? We know that the sides, any point on this perpendicular bisector right here, on this EA, is equidistant to the endpoints of the segment that it bisected. So we know that if this is 15, this side also has to be 15. Okay, and now we can do the same thing here, guys. Look, this is 90 degrees because of the linear pair theorem, right? If this is 90, what's 180 minus 90? 90. So we know that this is also a perpendicular bisector of what segment? DB. So now we know any point on this line, C is a point on this line, right? So C is going to be equidistant to the endpoints of the line segment that it bisected. So that means if this is 18, this also has to be 18. So now, what do we know about these two triangles? Well, they have congruent corresponding sides, they have congruent corresponding angles, and we know that the reflexive property of congruency tells us that AE is also congruent to AE. So now we know that these two triangles are what? Congruent. Because of what? ASS. But wait a minute, mister. ASS doesn't exist. That's not a real postulate. You're right. So what do we actually call this? What is the theorem or postulate or theorem that we can use to prove that two triangles are congruent if we have an angle and then two congruent corresponding sides? We call that HL. Only when it's a right angle. Okay, guys? You only use ASS, quotation marks on the ASS, when that A is a right angle. So by the HL theorem, these two triangles are congruent. Okay? So now, one more time. If you have a perpendicular bisector, any point on this perpendicular bisector, A is a point, is equidistant to the endpoints of the segment that was bisected. The same thing goes for angles, angle bisector. If I have an angle bisector, do we see how angle BAC was bisected? Through this, correct? Through this ray AE. So any point on this angle bisector, ray AE, is equidistant to the endpoints, to the perpendicular side of the angle that it bisected. So any point on this angle bisector is equidistant to the perpendicular sides of the angle that it bisected. So we know if this is 12, if FD is 12, whoops, if FD is 12, so is DG. My bad, guys. It's a little... Alright, whatever. So we know that this is also going to be, that this one's going to be 12 and this one's going to be 15, right? So let's take a look. What is it asking us? AE is the blank of BAC. Oh, that's just angle bisector. It wasn't even a question on any measurements. But we do know, if it would have asked us, what is the length of DG? We'd say 12. If it said, what is the length of BE? We'd say 15, right? And we know that AE, this ray, is an angle bisector. So here we go. What do we notice? Two arcs. An arc here and an arc here. So what do we know about this? This ray right here, not only is it ray CS, it's also a angle bisector, right? So now I know that if DT is 18, what does TK have to be? 18. So that's your answer right here. And if it would have asked us for LS, we would have had to say that it's 35. Okay? So let's take a look at this. Okay. Choose whether the figure shows a perpendicular bisector or an angle bisector. Well, we know it's not an angle bisector because no angle was bisected. There's no arcs. This is not an angle. This is not an angle. It's a what? It's a line segment. So we know we clearly have a perpendicular bisector, right? Because this line bisected this segment right here at a perpendicular angle. So we know that the figure shows a perpendicular bisector, and we know that line CD, very important guys, line CD is the perpendicular bisector of line segment AB. If this would have been like this, would this have been an accurate statement? No, that's impossible. You cannot bisect a line or a ray. Why? Because a line has no finite distance. So how could you find the middle of something that has no finite distance? Also, a ray goes on forever too. Okay? So you need to make sure that you understand, because it is very possible and that you'll see that they will have a drop box that you click on the drop box, and then it'll have line segment AB and line AB and ray AB, and they're going to trick you. Okay? So just understand that we understand what a perpendicular bisector actually does. So now we talked about this. Every point on CD is equidistant to points A and B. So what do you know about A and B? They have to be the what? The endpoints, right? So if we take a look here, line CD, every single point, every point on this line CD, whether it's here or here or here or somewhere over here that we don't know, lines go on forever, right, is going to be equidistant to the endpoints that were bisected. Okay? So now, what is the value of x? Okay, well, I notice, what's the first thing I notice? I know that I have a perpendicular line, a line segment right here, JK. And what's happening to this JK? It's being intersected at 90 degrees. Okay, well, is it a bisection? Tick mark, tick mark. So yes. So this is a line segment that is being perpendicularly bisected by line segment MB. And I know that any point on this line segment right here is going to be equidistant to the endpoints of the segment that was bisected. So now I just have to set 16x minus 24 equal to 4x. So minus 16x minus 16x. This is going to be negative 24 equals negative 12x. And x is equal to 2. Okay, so now let's look at this. Find the value of y. Okay, so if you guys remember on your quiz, I asked you, I think it was this exact diagram, and it said, what is the distance from L to F? And that was a little bit easy because it has a tick mark and a tick mark, so we know that answer would be 26. But now it's asking you to find the value of y. So it's asking me to find the value of this. Well, what do I know about this, about this figure right here? I have an angle H, H, right? KHF. I have this angle KHF being intersected, but is it an angle bisector? Do I have an arc here and an arc here? Are these two, can I make the claim that these two guys are congruent? Well, let's take a look at the figure again. If I have this ray HL if this were to be an angle bisector, then I would need any point on this HL to be equidistant to the what? To the sides of my angle. Are they? Yeah. Tick mark, tick mark. So I know that it's equidistant to the sides of the angle. So now I know that this HL, not only is it intersecting this KHF angle, it's also bisecting it. So we have one arc and one arc. So that means we could set this measurement and this measurement equal to each other. We can set KHL equal to FHL. So we have 6y equals 3y plus 9 minus 3y minus 3y. 3y equals 9, so y equals 3. Perfect. And now they asked us for y, so our answer is done. Our answer is that. But if they would have asked us what is the value of KHL, we would have had to plug this onto here. So our answer would have been 18. Now, would we even need to plug in this onto here? No, because we know if these are congruent angles, then the answer is just 18 if they would have asked us for what's the angle of FHL. Okay? Okay, what's this? Okay. So the way I'm viewing this is that I don't have any tick marks. I have an angle bisector, right? Okay, yeah. Oh, yeah. There you go. So I have this angle right here. I have this angle SVU, and I know that there's a line intersecting this angle, or a line segment intersecting this angle, line segment VT, and I know that there's one arc. So what does that tell me? What do I know about a point that is on an angle bisector? That it's equidistant to the sides of the angle. So I know now that Fy and Ty plus 6 have to be equal to each other. I could have also realized that was honestly the first thing that I realized was that I have an angle here, and then I have the reflexive property. So I would have had AAS. But however you guys want to do it, it doesn't matter. AAS, or you could have recognized that this is an angle bisector, and you know that any point on an angle bisector is equidistant to the sides of the angle that was bisected. However you guys want to do it. For y equals 2y plus 6. So 2y equals 6, and y equals 3 again, okay? So my y would equal 3. And now what's my ST? My ST would be 12. And do I even have to do the calculations for my TU? Absolutely not. Because I already know that ST and TU are congruent or equidistant. So, well, no, they're congruent. They're equidistant. The T is equidistant to the angle SVU. So if I wanted to be extra, I could do 2 times 3, which is 6. What's 6 plus 6 is 12. Okay. So once again, what do I have here? I have a line segment. And the fact that I have tick marks kind of clues me to the fact that I'm probably going to have some sort of bisection, right? Well, I am going to have a bisection. This Y is the midpoint. This Y is, if there's a line or ray or line segment that comes out of this Y, it's going to be something bisector. What type of bisector is it going to be? Perpendicular bisector. So what do we know about a perpendicular? What do we know about a point? A point on a perpendicular bisector in relation to the endpoints of the line that was bisected, they're equidistant. So we're going to set this equal to this. 2x equals 6x minus 8. So this would be negative 4x equals negative 8. So x is 2. Perfect. And now x is 2. And guys, always notice how I'm looking back and making sure that my final answer is actually that. Even though I know what I'm doing and, you know, I know the answers ahead of time because I've done this 100 times, I still have that instinct to go back and check because it's better safe to be sorry. So what is TW? TW is right here. So my x is 2, but my TW is 2x. So what's my final answer? 4. Okay. Okay, guys, you thought we were done with proofs? We're never done with proofs in geometry. Mwahaha. Okay, so, so let's take a look at this first segment. So we want to prove that AP is equal to BP. Well, we already know that because of our property of, we already know that about what we know about a point on a perpendicular bisector, right? So we know this is true, but let's write it out step by step. So if we have this first statement, it's right here, given. Okay, second statement, AM is congruent to BM. How do I know that? Because of the definition of bisector, guys. If there's a bisector, what do we know about the two line segments that it created? They're equidistant, they're congruent. So this next one, PM, it's given to us right here. So given. Now, angle PMA and angle PMB are right angles. Well, if they're both right angles, how do we know that they're both right angles? Because isn't that the definition of being perpendicular? They said that PM, that PM, right here in the given, they said that PM is perpendicular to AB. So if something is perpendicular, what type of angle do they form? 90 degrees. So that's why it's definition of perpendicular. Remember that this is the symbol for perpendicular, and this is the symbol for parallel. Now, they're being a little bit more specific about what the actual value of this PMA and this PMB are. So if we know that PMA and PMB are congruent, well, all they told me was that they're right angles. I don't know nothing about congruency, but what do we know about right angles? They're all congruent because they all equal what? 90 degrees. Okay, so now PM is congruent to PM. We should already know that. That's a reflexive property. And now, I'm going to write down everything I've gathered so far. So I know this is 90, and I know this. So what postulate tells me that these two triangles, this MPA and MPB are congruent? There's these two triangles, SAS. SAS postulate. So now, if once I've proven that two triangles are congruent, what can I then say about any other aspect? I can find out this and this now. I can find out this and this. I can find out these and these. Because of what rule? See, POCTAC, corresponding parts of congruent triangles are congruent. You guys have to know that. Or you can do CPCTC. I don't care which one you guys want to do. Okay? And then now we know that AP equals BP because of definition of congruency. Okay? So, same exact steps here. I'm given this. It's right here. Okay? Now they tell me that PQS is congruent to RQS. Well, how do I know that? Definition of angle bisectors. The same thing that we did over here for definition of bisector. We had that this segment was equal to this segment, except now in this case, remember, perpendicular bisectors bisect line segments. Angle bisectors bisect what? Angles. So now we just have angles. So definition of angle bisector. Now I have this that was given to me. Now, QPS and QRS are right angles. Well, how do I know they're right angles? Because I know that any point on an angle bisector is equidistant to the perpendicular side of the sides, to the perpendicular. I know that any point on an angle bisector is perpendicular and equidistant to the sides of the angle that was bisected. So now I know that this is the definition of perpendicular. Okay? Now, angle QPS and QRS are congruent because what? All right angles are congruent. We literally just did this, right? Now I know that QS is congruent to QS because of reflexive property. I know that angle triangle QSP is congruent to triangle QSR through what properties? Well, let's write down what we've written so far. We have, that's the only thing that we don't have given. We also have this and this, right? So now what property, so now which postulate tells us that these two triangles are congruent? AAS. AAS. Notice how I did not say ASA. If you want to say the statement ASA, this S has to be included between the two angles. It was not. It's not included, so it's just AAS. Okay? And now that I've proven that these two triangles are congruent, what can I say about these missing angles, these missing sides, everything else? I can prove everything else to be, and this side, I can prove everything else to be congruent to each other because of what rule? Sipaktak. Corresponding parts of congruent triangles are congruent. Okay? So that's it for the 5.1.